In this video, we want to talk about quadratic function. We mainly want to concentrate on how to convert quadratic function to its standard form. A quadratic function normally is given by this form. We refer this as general form. A quadratic function is a polynomial function of degree 2 with this form. And what is a standard form? A standard form is given by this here, a quadratic function, f(x) equals ax squared plus bx plus c can be expressed as this form. This is we refer this form as standard form. And the question is how we convert from a general form to standard form here. Okay, normally we try to do completing the square. Okay, why we want to use the standard form? Because standard form give us more information about the quadratic function. For example, and when we have the standard form, we get the h and k here. This h and k give us the vertex of the parabola. And also, when we have this form, we can easily identify the function's minimum or maximum there. Okay, so when we have a quadratic function, so if a is greater than 0, the graph opens upward. And so its vertex also give us the minimum value of this function because this is the lowest point of the graph. If you have the a less than 0, the graph opens downward. So the vertex also give us the maximum of the function because this is the highest point there. Okay. So now, this here we have summarized what we just talked about here. Let f be a quadratic function in the standard form. The maximum or minimum value of f occur at x equal to h. If a greater than 0, the function has minimum. If a less than 0, the function has maximum. Both occur at h, which means that's really occurred at the vertex there. Okay, so that's here just roughly give you the idea why we want to talk about standard form there. So let's take a look at a specific example and see how we solve a problem like this can. Okay, so let's take a look here. We have an example. A quadratic function f is given. We want to express f in standard form, means a times x minus h squared plus k there. We want to find vertex and x and y intercepts of f. We want to find the maximum or minimum value of f, sketch the graph, and find the domain and range of f. Okay, let's take a look here. First example, fx equals 2x squared plus 12x plus 10. And remember, in order to get the standard form, we have to complete the square. So let's take a look at how we complete the square. We rewrite the function. We put this two terms together and factor out a common factor, which is 2. Remember, when we do complete the square, we always make the leading coefficient 1. Okay, so here we factor out the 2 from first two term. You can see I get x squared plus 6x and plus 10. And remember, to complete the square, so you got what we did earlier. We know we need add the half of this coefficient square. Okay, so then we can complete the square. So which means we're going to write 2x squared plus 6x, add half of this coefficient square, which is 3 squared. But since you add 3 squared, so that means if you don't do anything, that means you change the function here. But of course, you don't want to change the function. You want this as perfect square. And so if you don't want to change the function to a different function, you add a number, which is 3 squared. You have to subtract the same number. Okay, so if you really cancel this two number, so that's still back to the original function here. Okay, but the question is why you want to do this? Because I want to write this in here as a perfect square. Okay, so now I'm going to write 2. So since this is a perfect square, which is x plus 3 squared, so now you can see you have to multiply that whole thing, which is this 2 times negative 3 squared. Negative, that's 3 squared, which is 9. 2 times 9, which is 18. So that's because this minus is minus 18 plus 10. Okay, so here now you have 2x plus 3 squared minus 8. So now we got the standard form. If we want to rewrite this, just want to compare with the ax squared, ax minus h squared plus k, we want to compare with that. So here we can rewrite this as x minus h. So here minus the h, which is going to be negative 3, plus k. So plus, since here is negative, so here plus negative 8 there. Okay, now that's in the standard form. We compare with this. So now you can see here your h is negative 3, your k is negative 8. Okay, so this is the h, this is the k. So now we write this in the standard form. That's fine. Okay, this way or this way, either way is fine there. But here we want to write this way, we just want to identify h and k, so we can easily write down the vertex there. Okay, so we got this vertex here. This is a vertex. So now, next thing here is we want to find x and y intercepts of f. To find the x, y intercepts here, actually, we don't need the standard form. We don't have to use standard form. We can just directly from here, from the general equation, to find the standard form. Okay, to find the x and y intercept. Okay, so let's see here. To find x intercept, okay, we set y equal to 0 and solve for x. Okay, so what we can do here is, as we mentioned, we can either use the general form or standard form. Either way is fine. Okay, if we use standard form, so that means you're going to have 2 times x plus 3 squared minus 8 equal to 0, because y is fx. So you got this equal to 0. So you got 2x plus 3 squared equal to 8. So you move 8 to other side. Both sides divided by 2, so you have 4 there. And then you square root both sides, so you have x plus 3 equal to square root 4, which is 2, but remember should be plus or minus 2. X plus 3 square root, is plus minus 2. Okay, always remember plus minus there. Okay, so here you x equal to minus 3, subtract 3 from both sides. So now I can separate this as x equal to negative 3 plus 2, which is negative 1, or x equals negative 3 minus 2, which is negative 5. So now you have x-intercepts, which is negative 1, 0, negative 5, 0. Okay, so here that's what we have in x-y-intercepts, x-intercepts. Now to find y-intercept, you set x equal to 0, solve for y. In this case, it's much easier because if you look at the original function in 2x squared plus 12x plus 10, if we use this way, it's actually much easier. When x equals 0, so it means that's equal to 0, that's equal to 0, you only get y equals 10. So you can see here, I got y equals 2 times 0 squared plus 6 times 0 plus 10. So that's only give you 10. So the y-intercept is x equals to 0, y equals 10. Okay, this is the y-intercept. Okay, so here, now let's take a look at what we next we want to find. Find the maximum or minimum value of f. Minimum value of f there. What do we try to do here? Okay, so and now you can see here, because the a, which is 2, greater than 0, so the function, okay, the graphs is open, okay, upward. Oh, open upward. And so opens upward, so that tells us, and the function must have minimum, okay? The function has a minimum. Okay, so which means when x equal to h, when x equals to h is negative 3, okay, f of negative 3 equal to negative 8, okay, this is the minimum. Okay, so we found a minimum. Let's answer the question C there. So now let's D, sketch the graph. Now we sketch the graph. To sketch the graph, we already get information. So here, let's go ahead and just sketch the graph. Sketch the graph. Here we have, first, when x equals negative 3 and y equals negative 8 there. So you have negative 3, negative 8. So here I want to use this negative 2, negative 4, negative 6, negative 8, negative 10, positive 2, positive 4, positive 6, positive 8, positive 10. Okay, 1, 2, 3. This is negative 1, negative 2, negative 3. This is 2, 4, 6, 8, 10. That's negative 2, negative 4, negative 6, negative 8, negative 10. Okay, so now let's see here. Negative 3, negative 8, which is negative 3, negative 8 is about here. Sketch the graph. And x-intercept is negative 1 and negative 5. Negative 1, 0, which is here. Negative 5, 0, which is here. Okay, And also the y-intercept, if you look, 0, 10. So which means it's here. Okay, so now we have those points there. Now we can sketch the graph, just connect those points. And remember, when we graph the function, make sure you graph, okay, always round smooth, okay, round smooth, okay, and don't ever to make the graph, okay, like make a turn like this, because quadratic function never make turn like this here. And sure, that thing you can keep doing like this here. Okay, so that's what we have, the graph there. Okay, so we sketch the graph, and remember the quadratic function always, the graph always the parabola, always symmetric about a vertical line which pass through the vertex. In that case is x equals -3. This line, the equation is x equals -3. So we refer this as the axis of symmetry. Okay, the axis of symmetry there. So that's we found the graph. So now next here says find the domain and range of the graph. Find the domain and range of the function f. For any polynomial, okay, any polynomial, if initially it does not give you any restriction, the domain always the same. The domain always the same, which means the domain for any polynomial always the same from negative infinity to positive infinity. Okay. And for the range, so you can see the graph is from -8 to infinity. So we get -8 to infinity. And remember, -8 included, so we use bracket. Okay, so that's how we actually solve a problem. Okay, how to convert the general form of quadratic form function to a standard form. And from standard form, we get more information, okay, than the general form. We can find a vertex, okay, we can find a minimum, maximum, okay, and also easily to find x, y intercepts, and now we can easily sketch the graph. Okay, that's the end of this video.